everyone. That clock I think is like a little 2-3 minutes behind. My clock shows is 9:30, so I start lecturing. How are you all doing? Good? How is the homework 2 coming along? Is it good? How many of you are still working on that? Okay. So tonight is the deadline, and as I said, I don't want to send you guys Canvas notifications every day that now is the deadline, so I just sent one. So previously I sent it right after I post it, or like a day after I post the homework assignment, but I decided to just send the announcement like a day before, or like the same day. So just know that every weekend you'll have a homework posted, And any questions so far? And I'm going to post your quiz 1 today. And the deadline for that would be not this Friday, the next one. So you have almost like 10 days to take the quiz. And how many of you went to the tutoring session? So how was it for the ones who attended? Was it good? So I gave your tutor a test bank that your book provided for me. So I'm going to also post the test bank on Canvas because there are like some multiple choice questions with just the final answer, but your tutor will go through them one by one and then explain why the solution is that, and also go through anything that you might need for your course in general. And as I told you, I'm going to add 0.5 points to your final grade out of 100 in this course. So it would be like 5 points out of 1,000. Does that make sense? For each tutoring session that you attend, to kind of encourage you guys to go to tutoring. And as I said, if you couldn't make it to the workshops, which are on Monday nights at like 6 p.m., just schedule another appointment at tutoring center, and then let them know that they should let me know, and then I add your grade that way. Does that make sense? Okay, before I progress with the lecture, any question about chapter 1? And how many of you have the book or like e-text? How many of you still didn't get it? So I highly encourage you to get it. I require the textbook because we have, like, as you see, so many materials, and to go through like 18 chapters, and I'm trying to cover 18 chapters because this is how my colleagues do, and they try to cover the whole book. So for that matter, I need to go faster and kind of like, just like go through some basic, general materials, and you study the rest, and this is how college in general would be. It's like different from high school or like your prior education, in the sense that, you should seek knowledge. I guide you, and then you should go learn the rest. So I cannot just tell you everything. And as you saw, I wanted to, based on the tentative schedule, I wanted to cover chapter 1 in 2 sessions, and it took me 4 sessions. But as I said, I put like more weight on the first chapter because I wanted you guys to know the basics. And I covered sections 1:1 to 1:13 of chapter 1. I may go back, and kind of like cover more, but I let you know. So as of right now, for your quiz 1, study the book. And if you didn't get it, get the book, just like get it as soon as you can, so you can just have the materials for your quiz 1. Okay, so for chapter 2, we're going to talk about alkanes. Does any of you know what is an alkane? And as I said, I'm going to post everything that I show you. I'm going to post on Canvas, so don't worry about taking the notes. And I have the lectures prepared the night before because it's faster in that way. I just don't want to write and then you write with me. It just takes lots of time. But I post everything that you need to know. So have any of you ever heard of alkanes? Have any of you heard of methane? Like propane, right? So in the gas that you use in your ovens and stoves, sometimes it's like methane, sometimes not. While I was living in New Hampshire, we had like propane, or like in some houses, it's propane gas. So these are types of alkanes. And we have like, again, you know, this is like organic chemistry, and we have like so many expressions, terms that I'll teach you, and some of them you should know by heart. If something, you know, I don't expect you to know, I'll tell you and give you the information in your exam. So you don't have to worry about like memorizing lots of things. But if I don't say anything, I expect you to know the things that I'm lecturing. Does that make sense? Okay, so we have like some expressions or like words here. So let me use like the green, I guess. Anyway, so we have like alkanes, cycloalkanes, and the chapter in general is about like conformational and geometric isomerism. So basically about like the structures of these alkanes and cycloalkanes. And as we progress with the chapter, I'll let you know what these terms each means. So as I told you, you know, like the main component of like natural gas in your, you know, at home, I mean, some of them is just like, you know, methane or propane. And in general, in petroleum and gas industry, the main components of the supply is, you know, materials that we call them hydrocarbons. So what are hydrocarbons? So can anyone guess, based on the name hydrocarbon, what constituents hydrocarbons have? What elements based on the name hydrocarbon? Yes?
Hydrogen, carbon.
Yes, so what did you want to say?
That's
Okay, yeah, so hydro, you know, as part of hydrogen, and then carbon. So they consist of hydrogen and carbon. And we have like three main categories of hydrocarbons. And that is based on the carbon-carbon bonds that we have. Can anyone see this color well, or is it like too sharp? Good? Okay, just let me know. As I said, you know, if I'm lecturing, if you don't understand what I'm saying, or you cannot read what I wrote, or like, you know, it is too bright, you cannot see, you know, just feel free to interrupt me at any time. So we have like three types of hydrocarbons based on the carbon-carbon bond. One type is the type that we only have single bonds. We call them saturated hydrocarbons. The other type is the ones that they have like double bonds or triple bonds, or combination of those. Double bonds, triple bonds. We call those types unsaturated hydrocarbons. And then we have another category that they have like cyclic functional groups that, you know, really similar, or they have like, you know, structures related to benzene structures. And as I go along with the course, I show you that what these cyclic structures mean. It means that they have in their structure, you know, a cyclic component to them. So, but as of right now, just, you know, learn the definitions. So if I have like an organic compound or hydrocarbon that it only has single bonds, what do we call that? Saturated. What about if they have like double bonds? What about triple bonds? If they have like a cyclic component to them, we call them aromatics. And as I said, as we go along with the chapter, these things become more clear, and I keep repeating them, so we won't be having any issues. So we divided hydrocarbons to three main categories: saturated, unsaturated, aromatic. And now saturated hydrocarbons again are being divided to two different, you know, categories. So remember, saturated ones were the ones that had like only single bonds, right? So two main categories are alkanes and cycloalkanes. So alkanes are acyclic, and then cycloalkanes are cyclic. So can anyone, based on the name, tell me what is cyclic or like acyclic? Anyone? So when A comes at the beginning of a word, what does that do?
Not.
What's that?
Doesn't it mean like not?
Exactly, you know. So we have like some words like symmetric, symmetric, right? When you add A, or like, what are some other examples? Can anyone come up with some other words that, what is it?
Asymmetrical.
Exactly, symmetrical, asymmetrical, right? So cyclic, it means that they form a cycle, kind of like when you write this structure. A cyclic means that they don't. And here also, so, and this is one part that I didn't cover in your book. I want to refer to the exactly. So I'm going to, since I didn't teach, this is like section 117. I guess I just changed this color. It's kind of bothering me. Okay, 117. So as I said, the sections that I don't cover in the class, I don't expect you to know in the exam, but you know, if I refer to them and write them in the board, anything that I talk in the class, I expect you to know. So I'm just going to write this here, but I wrote, you know, it's 117, so you can go back and then study more, you know, if you had like difficulties. So carbocyclic compounds, and you know, when we have like carbocyclic, it means that it has carbon, right? Contain rings of carbon atoms. And then you have like some examples written in page like 28, for instance, like benzene that we just talked about, right? Or like another example, if I can just do this, okay, can be like this structure. You see that they have like rings, they have like cyclic structures. So if they have like a ring in them, we call them cyclic, or like cycloalkanes. If they don't, we call them acyclic. Is that clear? So how many types of hydrocarbons do we have? Can anyone tell me? 3. So what are they? What was the third one? Exactly. So if I tell you how many types of saturated hydrocarbons we have? 2. Can anyone name them? Exactly. So is that clear? So we will be having lots of terminology, lots of different functional groups, different names, some of them really similar. So if you just like things from now, you know, with me, it would be like much easier. So alkanes. In general, alkanes have the chemical formula of CnH2n plus 2. So what does that mean is that if n equals 1, we write C1H2 multiplied by 1 plus 2. And remember from like your basic calculus course that when we have like multiplication and addition, we first do multiplication, right? So even if I don't write the parentheses here, first I should multiply 2 by 1 plus 2. Does that make sense? Any questions about that? So if n equals 1, I write C1H2 multiplied by 1 is 2 plus 2 would be 4. And then we can just not write 1, right? So C1H4 is like CH4. And we call that methane. Any questions? Good. Okay, so if n equals 2, I write C2H2 multiplied by 2 plus 2. And again, you can write or not write parentheses, but make sure first you multiply, then you add. So it would be C2H, 2 multiplied by 2 is 4 plus 2 is 6. C2H6. Does that make sense? And then if you do the same thing for like propane, and then n equals 3, it would be C3H. What would be the subscript for H? 8, right? So now tell me, if n equals 12, what would be the chemical formula?
C12H26.
Exactly, right? You multiply 12 by 2, so you write C12, H2 multiplied by 12 plus 2. This is 24 plus 2 would be 26. Does that make sense? So this is the first category of organic compounds that we're going to learn and then devote so much time to, alkanes. And how we name them, so you know now, hopefully, if you know the number of carbons, you can write the chemical formula. To name them, you add, so this is alkanes, like A-N-E, and alkanes is the category, right? But the name of each one would be alkane. And then it has like A-N-E at the end for all of them, and it shows that we have a saturated hydrocarbon, right? And these prefixes here, they show the number of carbon atoms. So it would be like meth, not the drug, just like the meth, for like the first one, right? So eth, like for the, if you have like 2 carbons, like prop for like 3, or like butane for like 4, like pentagon, or like, and let me go rewrite the so their names here, A and E, would be the same. So they are like alkane. And then here, from now on, it becomes like more familiar, hexa, is like hexagonal, the prefix is just more tangible, I guess. Hept for like 7, oct, like the, octopus example that I loved previously, it's kind of like, it means 8. And then non, it's kind of like, we had like nona when we wanted to name the molecular compounds, right? So, and then nano is kind of like, the root of them is similar if you just study like, literature or like, what is it, like linguistics, you'd see that the root of the words are similar, but, it's slightly different. But nano, is like 9, 10 to the power of minus 9. Anyway, deca is kind of like decade, right? It's like n equals 10. So, and then this is how we write the, did that go? Okay, here. So, CnH2 multiplied by 6 plus 2. Or like rather, the parentheses here. But again, you don't have to write the parentheses because we know we should first multiply, then add. And so whatever n here is the number of carbons, you put like n here too, and then find the number of hydrogens. So any question about alkanes? Is that clear? Okay. So, right. Oops. If I go to the next. Okay. So now we want to learn about the structure of alkanes. And again, if you learn the material that I taught you in the previous chapter, it should be like fairly straightforward. So ethane, now you know how to write the chemical formula. So what is ethane? Exactly. And then remember, it's like C2H, 2 multiplied by 2 plus 2. So this is 4. 4 plus 2 would be 6. And now when you want to write the structure, you have like, so I encourage you, if you have like difficulty writing like, chemical structures, first write the Lewis structures for all the elements. and then just like traditionally write the structure. But if you just like do that like several times, then you become comfortable that okay, carbon, it forms like 4 bonds, right? And for instance, this carbon here, we have like 4 bonds, and then the valence of carbon is like 4, right? And it has like so it's in group 4A, and it has 4 valence electrons, and it can form 4 bonds because 8 minus 4 is 4. So the valence of carbon is also 4, and it can form 4 chemical bonds, covalent bonds specifically with other elements, right? And then the same thing for this carbon, right? 1, 2, 3, 4, right? And hydrogen reach a duet, so it can maximum have like 1 chemical bond or covalent bond, because here it has 1 electron and then 2 electron. Is that clear? So in general, when you want to write ethane, you write 1 carbon and then have like, okay, 4 bonds, and then have another carbon, and then we attach carbons together, right? And we said that the ability of elements to have like really long chains with the same with themselves, basically. If we have carbon, we have like these carbon bonds. Does anyone remember what did we call that? Yes, so chain bond, but we had like a fancy word to describe that. Do you remember? It is started with
catenation.
Exactly, catenation. So when you want to write the chemical structures for like different compounds, remember for carbons they have this ability to just form bonds with each other, one another. So first work with carbons. So you have like C2 have like 2 carbons bonded together, right? And then for each of these carbons you have like 1, 2, 3, 4 bonds. Remember, the valence of carbon is 4. It can form 4 bonds. And then the same thing for this carbon, 1, 2, 3, 4. When we're all set with carbons, we start putting hydrogens for anything that is missing. So here, 1, 2, 3, 4, 5, 6. So this would be ethane. Is that clear? Any questions about ethane? Okay, and now do you remember that previously in the last session we said that sometimes we have like the abbreviated structural formulas, so you can see how these atoms bonded together but prevent writing this long structure. So this we can write like CH3, CH3. So it still tells me how these atoms bonded together, but it's but it's much shorter than this, and it is like better, or I guess it gives me structural information too compared to C2H6. So it's kind of like abbreviated structural formulas. Still, you know that okay, I have CH3, I have another CH3, so it gives you information about the structures of ethane, but C2H6 doesn't do that. It just says that you have 2 carbons, 6 hydrogen. Does that make sense? Or like propane. So can anyone tell me the molecular formula or chemical formula of propane? 8, right? And it had been C3H2 multiplied by 3 plus 2. Again, remember, you always multiply first, then add. But if that confuses you, put parentheses to make sure first multiply and then add. And now the same thing, you just put like the, carbons, so bond them together. We have like 3 carbons. And then, remember, the valence of carbon is 4, so they should form like 4 bonds. And then, put the hydrogens for all the bonds that are empty, the other side. Basically, we should put an element there. Or you can write CH3, CH2, CH3. This is the abbreviated chemical structure. Good? And then the same thing for butane. We have like C4H, what? 10, right? 2 multiplied by 4 plus 2. C4H 10. And then you have like C, and then you see how many carbons, how many hydrogen is needed for carbon to reach an octet, right? So here we know the valence of carbon is 4, so it already has 1 bond. We add like 3 more, 2 more, 2 more, 2 more, 1 here. And it would be like CH3, CH2, CH2, CH3. 3, CH2, CH2, CH3. Any question about? Yes?
So would your CH3s be considered radicals?
So if they are like separated from the structure and they have like,
Plus sign?
yes, and they have like a single electron here, we call that a radical, yes.
Okay.
But as in the structure itself, if it's attached, not,
Okay,
you know.
makes sense. Thank you.
Yeah, of course. Great question. Any other question? Okay. So now we're gonna name organic compounds. And this is the part that it gets a little tricky, so I need all of you guys' attention. And I encourage you, as I teach the class, just go home and review and then read the corresponding chapter at section in the book, because, you know, again, like the structures and then the formulas, now we're going to have so many names, and it may get tricky if you just don't follow the lecture. And your book gave some, you know, in section 2.2, explanation about like naming organic compounds and then how they were being named previously. So I encourage you to read that paragraph. And, you know, previously, based on some specific, you know, characteristics that an organic compound had, they would name that, but it was like specific for each, you know, organic compound. Right now we have like a systematic way of naming organic compounds, and we call that IUPAC. And your book, you know, kind of like wrote the pronunciation for people like me too, you know, so I know, you know, how to pronounce that. So it's kind of like IUPAC, you know. Anyway, so it's based on International Union of Pure and Applied Chemistry. So they came up, you know, it's kind of like SI units that people, you know, agree that, okay, if we have like length, we measure it with meter. It's kind of like established. So it's just like naming it. The name can be anything, right? But here, they came up with this systematic way of naming organic compounds. So if we know the rules, any compounds that we see, we can name that. And in that way, it would be like consistent for all elements. So it won't be a specific for like different ones, and we don't have to memorize, you know, like thousands of words for each compound. Now we have a systematic way of naming compounds. So, is it the, okay, I already went through that. Okay, anyway, so I have one extra slide. Okay, so, anyway, let me change my color. Okay, so now we want to study these IUPAC rules and how we should name the alkanes first, because we talked about alkanes rather, this session. And then anytime that I'm, you know, pronouncing something wrong, you know, or you don't understand, you know, just correct me, you know, I'll be happy. So don't worry about that. Okay. And as we talked about, we already named, you know, alkanes like methane, ethane, like propane. So, and those were acyclic, right? They weren't, you know, it was like these types of structures, they didn't have any ring in them, right? They were just like straight chain of carbons. So in general, we call them alkanes. And they, again, depending on how many carbons they have, they would be methane, ethane, propane, butane, and so forth. So this is kind of like review of just what we just said. But I included that because your book included that, and you have all the rules written nicely in these slides. And alkanes without branches are named according to the number of carbon atoms. Again, the methane, ethane, propane, and so forth. For alkanes with branches, the root name is that of the longest continuous chain of carbon atoms. What that means is that, let me have like one example here. So if you have, like for instance, this structure, CH3, CH, CH with branches. And then CH2, CH3, CH3, CH3. So what you do is that you try to find the longest chain that you can see. So one option can be this, right? It's just like a chain that I see. It's not a straight in the sense that, when written on the paper, but in general, it's a chain, right? So is this the longest one that we can find? No, right? This can be another chain. And when I say longest, it means that it should have the most number of carbon atoms. So it means that the root name, and I tell you momentarily what root name means. But we want to find the longest continuous chain of carbon atoms. So here, if I consider this one, so 1, 2, 3, 4, 5. Is this, consistent with this definition? Why not?
Because the top CH2 doesn't.
Exactly, it's not continuous, right? So what about, this is one good capability of this iPhone. Now you can play with the colors. What color do you guys like?
Yellow.
Yellow? Okay. So what about this one? How many carbon atoms it has? 5. So is that the longest chain? Exactly, it can be, right? Or you can also argue that this one, 1, 2, 3, 4, 5, that can be considered the longest chain too. But in general, in theory, this is how you find the longest chain. You have like a continuous, chain of carbons. Try to find the one that has like the most number of carbon atoms. So this is like the first step for the structures that they have like branches. Is that clear? Okay. Now that is okay. And here I already wrote the example, but I guess it was good that I just went through it myself too. So the longest continuous chain in color has 5 carbon atoms. The compound is therefore named as a substituted pentane. So when you want, so that is what we mean with the root name. So when you want to name this, you name it based on 5 carbon atoms. And you remember from like previous slides that when we had like 5 carbon atoms, what did we call the alkane? Exactly. So when we want to name this compound, the root name would be pentane. And as we, go through like the next slides, I teach you the other rules, and then you can name this compound. But before I do that, any questions?
So would you say it's a substituted pentane, or would you just call it pentane?
So we add like the other, prefixes and then like other parts to it. Yeah. but we don't use the word substituted in naming that, but this is what it means. Great question. Any other questions? Good. When we want to, we have like 1, 2, 3, 4, 5, right? So when we have like branches, we cannot just like write ethane, propane, and so forth. The naming has like more to it. So the first one was to see what is the main chain, right? And then the one that has the most number of carbon atoms. And then the next step is to name the carbons. And based on, if I name this as like 1, 2, 3, 4, 5. So here, for the first one that I wrote here, the first chain or the first substituent that I encounter has the number 2. For the other naming 1, 2, 3 here, the first substituent that I encounter has the number 3. Which one is lower? 2. So this is the way that I should name. Does that make sense? So when we name the carbons, right, we should name it somehow, and you can just do both, see which one gives you the lowest number. So when you first see the first substituent, that should have the lowest number possible between the two naming that you do. So if I do the first one, it would be like 2, the number here, right? If I do the other way around, the first substituent would have the number 3. So for that matter, we do this one. Good? And as I said, questions?
Yes. Is there ever a point where you actually do name it backwards? Or do you always from left to right?
Yes, there are, if I just put like this, if I looking for my black. Okay. If I just like put this carb, instead of this having this branch here, I have it the other side, right? We would name the other way around.
Oh, okay.
And then you encounter like several structures, so you'll see all possibilities. So, any other questions? Great questions. Okay, so this was another rule. The fourth one is that groups attached to the main chain are called substituents. So we have like a main chain, and how do we find main chain? Based on what I just said in the previous slide.
The longest carbon.
Exactly. The chain that has the longest number of carbon atoms, and it should be like continuous. You can just like, basically the same thing that I did. Try not to move your, pen or pencil out of the, don't, what do you call it? Try to be continuous, without like, without interruptions, or like your pen would be on the, so if you have like this structure, try to do this 1, 2, 3, so the continuous movement on your pen on the piece of paper. Anyway, you know what I'm talking about. And saturated substituents that contain only carbon and hydrogen are called alkyl groups. So how do I know that I have saturated substituents?
Single bonds.
Exactly. If they have single bonds, they are saturated hydrocarbons, or like saturated substituents. So we have like the root and then the main chain, and we have like substituents, right? And if these saturated substituents, meaning that like they have like single bonds, if they only contain carbon and hydrogen, we call them alkyl groups. So basically, if we have like ethane, its alkyl would be ethyl, or like methane, its alkyl would be methyl. Does that make sense? So we use like this alkane as a general name, and then we change it to alkyl. like methyl, ethyl, propyl, and so forth. Does that make sense? Are you still with me? Okay. An alkyl group is named by taking the name of the alkane with the same number of carbon atoms and changing the ane ending to -il. So what I just said. Here, okay. So now, for instance, if you have like methane, CH4, kind of like similar to what your friend asked, that is this now CH3, is this a methyl? So the answer is yes, if we just separate it from the structure. So CH3, we call that like methyl, or we can show it with like ME as an abbreviation for methyl. Does that make sense? Atoms, for instance, number. Oh, okay. So the fifth rule. The main chain is numbered in such a way that the first substituent encountered along the chain receives the lowest possible number. So what does that mean is that, I guess I write the example after I finish this slide. So we name the carbon. The main chain is numbered in such a way that the first substituent encountered along the chain receives the lowest possible. Okay, let me go back here. And each substituent is then located by its name and by the number of the carbon atoms to which it is attached. And again, we're going to go through some examples, and I review all these rules after I finish writing this, so it would be much more clear. If you have when two, and I kind of wrote this here so you see what I wrote in the previous slide here too, I guess I can zoom it a little. When two or more identical groups are attached to the main chain, prefixes such as di, tri, and tetra are used. Is that clear what it means? So for instance, let me see if I wrote a different one. Okay. For instance, if we have, and let me just finish this because I wrote examples already at the end of this, and then we go through some examples. Every substituent must be named and numbered. So you see you have your main chain, right? And you name the carbons somehow that you reach the substituent first, or when you write it, that corresponding carbon has the lowest number possible, right? And now you have these branches that you should name too, right? Or these substituents, these branches we call substituents, right? So every substituent must be named and numbered. So we want to write the name of the organic compounds, right? If you only have the name of the main chain, right? So here we have 5 carbons in the main chain, and if you just say pentane, so what is the difference with the alkane, right? So we should distinguish that. So for that matter, what distinguishes that? The substituents, right? So you should name and number them. Even if 2 identical substituents are attached to the same carbon of the main chain. So what that means is that if in the same chain you have I guess this cannot be a good example again, because carbon, do you know why that wasn't a good example? Why can't I have another carbon here?
It only has 4 bonds.
Exactly. So
Because what?
because we have if I put another carbon here, carbon would be having so it has 1 bond with hydrogen here, 1 with carbon here, 1 with carbon here, 1 with carbon here. So if I put another carbon here, it would be having 5 covalent bonds, and that is not possible. But in general, remember these rules. Now I'm going, after finishing this one, I know with examples written, and it would be like more clear. Wow, it's already 10:15. It passed so quickly. So, okay. Every substituent. Oh, is it like? Okay, here I wrote the example. Okay, must be named and numbered even if two identical substituents are attached to the same carbon of the main chain. So here, again. So how do we recognize the main chain? The longest one, right? If I, count this one, it would be 1, 2, 3, or 1, 2, 3, 4, right? They're not the longest one. The longest one is this one, right? And what I do is that when I want to name them, if I name them 1, 2, 3, 4, 5, I encounter the branch or substituent first, and the number would be 2. But if I name it this way, 1, 2, 3, it would be like 3. So I name them this way. So I encounter the carbon, this branch first. Does that make sense? So what I mean is that, let me just paraphrase. I just write the same structure here. I have CH3 here, CH3. So is this thing clear how to find the main chain? Right? We count the number of carbons, and this is like 5. So I want to see whether I should, so there is 2 ways, and then we always name continuously, right? I don't name these as like 1, 2, that is like a bad idea. I don't name them as like 1, 2, 3, 5, 6, right? The carbons, I don't just name them randomly, right? So we have 2 ways. Whether start naming from here, say carbon 1, 2, 3, 4, 5, or from here, 1, 2, 3, 4, 5, right? And in order to see which one I should do, you can just write both and then see which one gives you the lowest number of carbons. What I mean is that you can write them and then see in which one you encounter the branch first. Yes?
What would you do if you had like another CH3 on the other side of the second CH3 there?
So like here?
No, on the, so after the second CH3 up top.
Uh-huh.
If there were like just 3 up there. Like, so from the 4th carbon to going this way, if you had a CH3 above that, would you just go left to right still?
Oh, if I had here? Okay, so if I had here, you could technically go from both sides, and then to decide how to do that is the next rule that I'm going to tell you. If you have like the identical number of carbons, but it's listed right after this. Okay, so again, so is this one clear to how to name them? Okay, have like the rules. So now, if 2 is basically the question that you asked. If 2 or more different types of substituents are present, they are listed. Or I guess this is the next one after this one, the question that you asked. If 2 or more different types of substituents are present, they are listed alphabetically, except that prefixes such as di and tri are not considered when alphabetizing. And again, we go through all these rules in the next slide too, probably next session. Punctuation is important when writing IUPAC names. IUPAC names for hydrocarbons are written as one word. Numbers are separated from each other by commas and are separated from letters by hyphens. There is no space between the last named substituent and the name of the parent alkane that follows it. So here I listed all the rules that I just mentioned and then gave you example. So can you guys just take a picture of the attendance, and then just when you walk out of the class before your next class, just do it as soon as you can. And then if you couldn't do that or you were busy, just send me an email that you were in the class. Yeah, this lecture went much slower than I anticipated. In my head, I was like, okay, I won't be having enough slides today, and I was writing this last night, but just like time flew by. Make sure to finish the homework assignment and then read the book, and just email me with any questions.
So, on the tutoring, I can't make the workshop on Monday just because I'm like busy, but I have, like, for example, I went yesterday afternoon. Could that still count for my, like, extra credit?
Yes, just let your, was it Sean, your tutor, or was it different
It was
person?
Celeste.
Can you just tell her to send me an email
Okay.
that you attended?
Okay.
Yeah.
Because they make me check in when I get there anyways.
Yeah.
Okay, so yeah, I'll
But
just do
because
that.
automatically they don't give me the names.
Oh, really?
Yeah.
Okay,
So
yeah, I'll
I mean,
just tell
my
Celeste.
tutor, I asked him to give me the names of students who attended, but other than that, when you go to tutoring, they don't, email
Oh,
me
okay, that makes
automatically.
sense.
So just let them know and let me know, so I keep track of that.
Okay, sounds good. Thank you.
Thank you.